Hi, today for our experiment, Laura, Kevin, and I will be doing an experiment to prove that a glass of water can be used as a convex lens. Today for our experiment, our materials will be a laser and a glass beaker. So Kevin will now explain what a laser is.
A laser is a device that generates an intense beam of coherent monochromatic light by stimulated emission of photons from excited atoms or molecules. Lasers are used in drilling and cutting, alignment and guidance, and in surgery. The optical properties are exploited in holography, reading barcodes, and recording and playing compact discs.
And Kevin will now explain how this glass of water can be used as a convex lens and show how what a convex lens is.
Okay, so a convex lens is an optical device which transmits and refracts lights, converging or diverging the beam. What separates a convex lens from a concave lens is the convex lens is thicker at the center.
So this is a laser in action.
Laser stands for light amplification by stimulated emission of radiation. For our experiment, we drew 5 rays, and as we put the laser on the first one, you could see that the laser does not go straight through. It actually goes off at an angle, and as we move the laser along, you can see that the laser
keeps on moving at an angle as it moves across the wall. So basically, this proves that the light is bending, and ultimately shows that this glass of water can be used as a convex lens.
I'm going to draw some diagrams of how our experiment is set up. So first, I want to draw a top view of how the experiment will look like. So here are how the rays would go if we were able to have 5 lasers, but unfortunately we only have 1. Okay. And so this would be the wall. And remember, this is from a top view. So this is view from above. And this is the beaker. So the laser, I'm going to use red to draw that. And it would be this line here. And from above, it'll look like it's hitting the wall here. Okay. So now from a side view, this will show more detail about how we're setting this up. And again with the rays. And so here's the wall. So since the water and the beaker will act as a convex lens, the way that the laser will reflect it will be bending it. So if here's the laser light, once it hits the side of the beaker, I'll mark this point in blue, it will go, and if this is the center line, then the light will then bend more towards the center until it hits the other side of the glass. And by the time it hits the wall, the path of the laser light will be up here. So these 3 points are important. And this is the path of the laser light. Okay, and one last diagram would be the ray diagram. And this will show how if we had 5 lasers, it would be able to create something that looks like this. Okay, and pretend the circle is circular. Okay. And so all the rays would start to come together. And then when they hit this side, they'll come together even further. Until they all converge into a focus point. I need to make that blue. So this would be the focus. And then the rays would continue on from their previous path until this would be the wall. Well, the wall would be here, and this would be the spreading of light. And this is also the view from above. Okay. As seen in the ray diagrams before, you can see how the glass acts as a convex lens. So basically, as a biconvex lens. A biconvex lens is a type of converging lens, and this lens, the way we can tell it was convex is because the incident light rays, as shown by this laser, they are parallel to the axis of the lens, like this, and when the laser point light went through, they all converged, as seen in the ray diagram before, to a focal point and on the opposite side of the lens. So this is how we could tell that it was a biconvex lens, thus proving our hypothesis. Thanks for watching!